good day to you, my dear student. Now, in this video, we will be learning about how to simplify equations in one variable. So again, when we say one variable, there's only just one letter that is present in a certain equation. So you can only see all x's or all y's or all z's. So there is just one variable in each of the equations. Now, in order for us to be helped on solving equations in one variable, there are different properties that we need to remember. First is the reflexive property, and reflexive property states that a number, a real number, is always equal to itself. So I will write here, let's say the real number is A, then A is always equal to A. If it's B, the real number is represented by B, then that will be always equal to B. That is the reflexive property. Now for the symmetric property, this just tells us that the sides of the equations can be interchanged and they will still be the same. You will still have the same result. Like for example, if A is equal to B, then B is also equal to A. So as you can see in our first equation, A is the one written on the left and B is the one on the right. So this is just the same as when B is on the left and A is on the right. As long as you don't change anything in the equation, it is symmetric property. There's also another rule or another property of equivalence, which is transitive property. This involves, let's say, real numbers A, B, and C. So all of them are real numbers, okay? Same thing with the one in reflexive and symmetric. So if A is equal to B, and then B is also equal to C, then we can say that A is equal to C. So as you can see, if you would put this in terms of if in terms of example, if for example, um, 4 is equal to 2 plus 1 and 4 is equal to 2 plus 2 and 2 plus 2 is equal to 3 plus 1, then 4 is also equal to 3 plus 1. That is what is meant by the transitive property of equality. So if one real number is equivalent to two real numbers or equal to two real numbers, then those two real numbers are also. Next, in this lesson, which is simplifying equations in one variable, the next two properties are very crucial or it's important. So we need to also understand that there are properties of equality in real numbers. So this one is equivalence, this one is equality. We have the addition property of equality or the APE. So it says here that if A and B are real numbers and they are equal to each other, then I can add another real number C to both sides and still they will yield the same result. So again, if A and B are real numbers and then they are equal to each other, so A is equal to B, then if I add another real number C to both sides of the equation, the answer will still be the same or they will still be equivalent. Um, let's try to illustrate it. So for example, A is equal to 1 and B is equal to 1. Okay. So if I add, let's say C is equal to 2. So if I add here A, so 1 plus 2 is equal to B is 1, so 1 plus 2, it will still be 1. That is what is meant by the addition property of equality. As long as as long as two real numbers are equal, if you add another real number to each of them, the answer will still yield the equivalent value. Just erase this one. Okay. Next is we also have the multiplication property of equality or the MPE. It's also similar to APE, but this time it's multiplication, right? So if A and B are real numbers and both of them are equal to one another, then if I multiply a real number c to them, to both of them, then the answer will still be equivalent. So for example, I multiply c on both sides of the equation, they will still be equal as long as a and b are real numbers and they are equal. Okay, so these are the properties that would help us to solve equations in one variable. So let us try to apply these in examples. I'll just change to blue so that it's clear that these are examples. So for example, I have here x plus 3 equals 10. So I want to solve for x. So that means if you want to solve for a certain variable, that would mean you need to eliminate all the other terms or other numbers that are in the same side of the variable. So you need to isolate the variable. So that's the term. You need to isolate the variable so that you would be able to solve it. So how do we isolate? So I have here x plus 3 equals 10. And according to this equation, x plus 3 is equal to 10. So I would try to apply the addition property of equality because it says that if this one is my A and this one is my B, then A is equal to B. And then it says that if I add a number or another real number, then on both sides of the equation, then it will still yield an equality. Okay? So I want to get rid of a positive 3 or 3. So I need to add the opposite of positive 3 because according to the identity or according to the property of addition, that when we add the inverse of it, the inverse property of addition, the inverse of a positive number is a negative number, then the answer will yield 0. And if this 3 becomes 0, then x will only be left, will the only be the one left in the left side of the equation. So I will subtract or add negative 3 to both sides of the equation so that 3 plus negative 3, that would cancel. That's 0. So it will become x only here. And then 10 plus negative 3 or 10 minus 3 would give me positive 7. Hence, I have already here x is equal to 7. So this is now the value of x. So how would you know if it's correct? So let's check. I'll use a red pen for that. Let's check if x is equal to 7 is the true answer or the true value for x here. So x plus 3 is equal to 10. So x is 7. So 7 plus 3, that is equal to 10. So hence our answer is x is equal to 7. Okay. So again, what we used here is the property of addition, property of equality, because there's x and 3 are in addition. They have the addition sign, and we want to get rid of 3 because we want x to be isolated on the left side. So let's try another one. Let's try m minus 4 equals 7. So again, the technique here is we have to isolate the variable. And when we say isolate the variable, the variable has to be left alone on one side. So looking at this, so m minus 4 equals 7. There's a subtraction sign here. I can also use the addition property of equality here by adding the inverse of negative 4, which is positive 4. So using APE, m minus 4 plus 4 is equal to 7 plus 4. Again, if you're using addition property equality, whatever you add to the left should be added also to the right. That would make the equality still true. So this one cancels because negative 4 plus 4 is 0. So m will be left alone in the left side, and 7 plus 4 is 11. Therefore, m is equal to 11 in order for this equality to become true. Again, let us check. So we have m minus 4 is equal to 7. So m is 11 minus 4. Yeah, that's equal to 7. So yeah, that's how you apply the addition property of equality in solving for um, sorry, equations in one variable. So let's have more examples. Let's look at this. Let's have 3x equals 12. Okay. So in this case, I don't have an addition sign or a subtraction sign. The operation here is multiplication. So I can apply here multiplication property of equality. And it states there that if A and B are real numbers and they are equal to each other, I can multiply a number to both of them, to both sides of the equation, and then yet the equality will still hold true. So again, the technique is isolate the variable. So I want to isolate x here. However, it's multiplication. So what's the inverse of multiplication? Parang division. But if you look at the inverse of a certain number, if you would recall the inverse of a number, it's actually the reciprocal of that number. So if the number that I want to eliminate is 3, then I have to multiply the whole equation by the reciprocal of 3 so that I can get rid of it on the left side. So the reciprocal of 3 is actually 1/3, right? Because 3 times 1/3 will give you 1. And if you have 1 in beside x, you don't need to write 1 anymore. It will just stay as x. So I will multiply um, 1/3 to 3x and also 1/3 to 12. Because again, whatever you do on the left should be done on the right. So what is 1/3 of 3x? So 3 and 3 will cancel, and what will just remain is x, because I don't need to write 1 anymore, because it's understood that if there's no number at the left or there's no numerical coefficient present, that is 1. And then 3 and 12, that gives us 4, or 12 divided by 3 is 4. Therefore, x is 4 in order for our equation or equality to be correct. So let's have to check. Let's need to check. There's a need to check. So let's have 3x equals 12. Let's check if that's true. So 3 times, if x is 4, 3 times 4 is equal to 12. Hence, our answer is x is equal to 4. Let's practice more so that you will have a thorough understanding on this. Let's have x over 4 is equal to 15. So by looking at it, we can't use the addition property of equality here because there's no addition sign. We can't see addition or subtraction here. But what we have here is evidently you will say division because x over 4, that's division. But it's also multiplication in a sense because it's also 1/4 times x. But yeah, we can use the multiplication property of equality here. And again, we have the variable, we need to isolate, isolate the variable. So I need to isolate x, but I have here, this one is also the same as 1/4 x. That is just the same as x over 4. If you multiply the numerators and then multiply the denominators. So it's still x over 4. So the number here is 1/4, and I want to get rid of 1/4 on the left side. And in order for me to do that, I have to multiply that to its reciprocal. And the reciprocal of 1/4 is 4 because it will yield 1. So this is the reciprocal. So I will multiply the whole equation, both sides of the equation, by 4. So this one will cancel. I will just have the x on the left side. And then 15 times 4, that's actually 60, right? So that means x is equal to 16. But again, we have to check if this holds true to our equation. So x over 4, is it equal to 15? No? When x is equal to 16. So 60 divided by 4 is indeed equal to 50. So that is how we will be applying the multiplication property of equality. Okay, so let's have one last example before we go to a certain technique that would eliminate some of the steps when we're solving. but still applies the properties of equality that we have just discussed. So let us try this last example. We have, this is actually example number 5. So 4n over 2 plus 2 is equal to 6. Okay, so this is a bit tricky because there's a multiplication or division here and then there's addition. So what are we going to do? Okay, so we do it step by step. But because our goal is to isolate the variable again. That is our goal, to isolate the variable. So let's try doing the easiest part is first to get rid of 2 because here is m. Marami siyang kasama, 4, 2, and 2. So let's try to get rid of 2 on the left side. And since it's plus, I can use the addition property of equality and add to both sides of the equation the inverse of 2, which is negative 2. So I will put here 4m over 2 plus 2 minus 2, or sorry, not minus 2. So I have to show it that it's actually addition. Okay, so you might get that. So plus negative 2 is equal to 6 plus negative 2. Okay, so in this case, this one will cancel already because that will give you a zero answer, a zero sum. So what will be left here is 4n over 2. Okay, and then what we will have here would be 6 plus negative 2, so that would be subtraction, and then the answer would be 4, positive 4. Now, I still have to eliminate 4 and 2 in my 4 and 2 in my left side because I want to just have the n. As you can see, I can simplify 4 and 2, right? So 4 and 2, you can eliminate that. You can cancel that, and what remains is 2. So I will already have 2n equals 4. And then using the multiplication property of equality, I can multiply by the reciprocal of the coefficient, which is 2. And the reciprocal of the coefficient 2 is 1/2. So I will multiply both sides of the equation to 1/2. And this one cancels. What we'll have is m here on the left side, and then 4, 1/2 of 4 is 2. Then this is our value. Now let's check if that is true. So we have 4n over 2 plus 2 equals 6. So if we let n equal to 2, we have 4 times 2 over 2 plus 2 is that equal to 6. So we have 4 times 2 is 8. 8 divided by 2 is 4. 4 plus 2 is, yes, equal to 6. Therefore, the m equals 2 is a true solution in our equation. So that is how you apply here. As how you solve using the addition property of equality and multiplication property of equality for equations with one variable. But as I said a while ago, we can actually use a shortcut method for this, but still applies this concept of APN and PP. And this is what we call the transposition method. I know that you have heard of this one. So using the transposition method, it's just it means that you are transferring one value in an equation to the other side. Okay, so let's have the example. But of course, when you transpose to the other side, you have to make sure that your sign changes. And you can only do transposition when there is an addition or subtraction operation on one side of the equation. So again, transposition is only possible for addition or subtraction. So let's just have the first example that we have. The x plus 3 equals 10. So what we did here was to subtract, right? So to add the reciprocal. So if you want to do a shortcut method of this, all you have to do is transpose to get rid of positive 3 on the left side of the equation. All you need to do is transpose it to the right side, what you don't need, which is 3. Again, you can only use this for addition. And as you can see, there's addition sign here. So if you transpose 3 to the right side, it will become negative 3. The sign will change. If you take a look at what we have added here on the right side, you can see that it's negative 3 here. So it's actually the opposite or the inverse of the one in the right side. So negative 3. If you also look here on our second example, we have here negative 4, and what we added on the right side is positive 4. So you have to make sure that when you transpose a number or a variable to the other side, then the sign should change. Okay, so that means this will be x is equal to 10. When I transpose 3 to the right side, it becomes minus 3. Then x is equal to 7. You will still yield the same answer. Doing that on the second, which is m minus 4 equals 7. If you transpose that one, make sure that you change the sign. So m is equal to 7 plus 4, and that would give you 11. Again, transposition is only for addition, or if you can see a subtraction sign. Okay, so if there's no addition or subtraction there, then transposition cannot be used. Okay, so how about what if it's a multiplication? What can we do? Okay, so um, sorry, not number 2. Let's try this one. Or number 3 example, we have 3x equals 12. So how do we do that? How do we get rid of 3x or 3 there? Okay, so in multiplication, the reverse of multiplication is actually division, right? So if I want to get rid of 3 here, I simply divide both equations by 3, which is actually the same as what happened here when we apply the multiplication property of equality. So we're just doing a shortcut. We actually divided 12 by 3. 12 divided by 3. That also holds true for this one. So 1/4, since this is division, no, it's a fraction. In order to get rid of that, we just multiplied 4 so that the reverse will happen. So that's the thing that you can do for x. So if you have multiplication and you want to get rid of the coefficient of a certain variable, then you divide both sides of the equation by the numerical coefficient. Then it will cancel. Then you will have just x equals 4. If we want to apply that in the longer example, the 4m over 2 plus 2 equals 6, then first thing that we need to do is to apply transposition. So transpose 2 to the right side, there's addition here. So 4m over 2 is equal to 6 minus 2. Again, when you transpose, the sign should change. So if it's plus here, it has to be minus on the right side. So we will have a 4m over 2 is equal to 4. And then we can again simplify this one to 2m. 2m equals 4. And then based on the example in 3, if you have a coefficient in the variable, just simply divide that. If it's multiplication, divide. So 2 divided by 2, that's 1. It's m. 4 divided by 2 is. That still gives you the same answer. Okay. So that is how we will solve equations in one variable. So let's have more practice using the transposition method, or if applying the long method on AP and MP is more applicable to you, then that's fine. But yes, we can use transposition for a shortcut to eliminate some of the steps in our solution. So let's try to practice on solving. So let's solve for the unknown variable. So let's have 6y is equal to 12 minus 2y plus 4. Okay, so in this case, in the left side, you have their y, but in the right side, you also have y. So what you need to do here is to isolate all the terms that has a variable, and in this case, it's y. So that means this y on the right side should be transposed to the left side so that all the y's are there. Okay, so in order for me to do that, I will just change the sign because there's subtraction here. And again, transposition can be used when there is an operation of addition or subtraction. So if I transpose negative 2y to the right side, it will become positive 2y. Okay, 12 and 4, I don't need to move them. They have to be just there. So I will just write 12 plus 4, and then I'll simplify it later. Now, what is 6y plus 2y? Of course, you can add them because they are like terms. So 6y and 2y, that gives you 8y. 12 plus 4, that gives you 16. And is this familiar? So there's a multiplication here on the variable and the numerical coefficient, and we want to get rid of the numerical coefficient to isolate y. Hence, I can divide by 8. Then y is equal to 16 divided by 8 is 2. Now we have to make sure that we are right. We are on the right track. So you have to check if your answer is correct, or if y is equal to 2 is a true root or a true solution for this one. So we'll have 6y equals 12 minus 2y plus 4. So I will I will substitute rather 2 to y. So 6 times 2 is equal to 12 minus 2 times 2 plus 4. 6 times 2 is 12. 12 minus 2 times 2 is 4 plus 4. Oh, this one cancels, negative 4 and 4, and that will give you an answer of 12 is equal to 12. Hence, our final answer is y is equal to 2. It is a true solution. Okay, let's try another one. Let's have 5 times x minus 2 equals 4 times 2x plus 5. No, this is a more complicated one. But if you remember the distributive property of multiplication over addition, or distributive property of multiplication, then what you can do here is to distribute first 5, to all the numbers inside, and also 4 on all the numbers inside the parentheses. So if I solve that, I'll just use red. So we have 5 times x is 5x, 5 times negative 2 is negative 10, is equal to 4 times 2x, that is 8x, plus 4 times 5 is 20. Now, again, we have to isolate all the variables with x, or all the terms with a variable. In this case, it's x. So what I need to do, I have here 8x. I can transpose it to the left side. And then 10 here, I don't need negative 10 here. So I have to transpose it to the right side. Okay, so 5x, I will transpose 8x. It's positive here, so it will become negative on the left side. Equals, I will write 20 because I'm not moving it, but I have to move negative 10 to the right side. So negative 10, if I put it on the right side, will become positive 10. And then I will solve. So 5x minus 8x is actually negative 3x, and 20 plus 10 is 30. This is again familiar. We can divide by negative 3 so that we can cancel, or we can remove the numerical coefficient. So negative 3 times divided by negative 3 rather is 1. So I have here x only, and 30 divided by negative 3 is 10. Now again, let us check if our answer is, if our solution is a true solution. So we have here 5x minus 2 equals 4 times 2x plus 5. So 5 times negative 10 minus 2, is that equal to 4 times 2 times negative 10 plus 5? Okay, so let's check. So 5 times negative 10 and negative 2, that gives you negative 12. And then 2 times negative 10 is negative 20 plus 5. So 5 times negative 12 is negative 60. Negative 20 plus 15, that gives you negative 15. Wow, yeah, negative 60 is indeed equal to negative 60 by the reflexive property. Yes, our answer is correct. Or actually, our answer is a true solution because there are some solutions that are not true. But in this case, because it makes the equation, the size of the equation equal, then it's a true solution. Okay, so let's try one last example. So let's have 5x over 6 minus 3 plus x over 5 equals 4 over 3. Oh, this is a bit complex. Though. It has a lot of fractions. So how do we deal with this? How do we isolate the variable or the terms with the variable? So remember the concept of LCD. What is the LCD of 6, 5, and 3? Or what is the least common multiple of 6, 5, and 3? And we will use that as a multiplier for the whole equation so that we can get rid of the denominator. So 6, 5, and 3, the GCF, or sorry, the LCM of that is, I believe it's 30. So we multiply both sides of the equation by 30. So 30 divided by 6, that would give you 5. So you need to multiply that with the numerator. Because if you cancel that, it will become 5. So it multiplies 5 times 5 x. Minus 30 and 5, if you cancel that, it will give you 6 as a numerator. Then it has to multiply with that 3 plus x. 30 divided by 3, or 30 you cancel to 3 is 10. Then you have to multiply that with the numerator. So there's no more denominator, right? So all we need to do is to make sure that the parentheses are removed by multiplying the ones on the outside. So 5 times 5x is 25x minus 18 minus 6x is equal to 40. And then let's just inspect. So we have 25x and 6x. So it has to be on the same side, but you don't need this one. So you can transpose that to the other side because it's a constant. So we have here 25x minus 6x. Again, the signs of 25x and 6x will not change because they are not moved to another side. But 18, 40, I will copy. It's not moving, but 18 is the one moving, so it will become plus. And 25 minus 6 is what? 25 minus 6 is 90, right? 25 minus 6 is 19. So that is just to make sure. Sometimes my subtraction and addition fails. Okay, 19x. Okay, it's equal to 40 plus 18. What is 40 plus 18? That is 58. So this is familiar now. And what we do here, if there's multiplication on the variable and numerical coefficient, we divide by the numerical coefficient. So divided by 19. So x is equal to, we know that na 58 can be divided by 19. And we can't divide that. So that means our answer will not be exact. So 58 divided by 19 will give us around 3. 3 as a whole number, so 19 times 3. So it would give us 3 and 1 over 19. Okay. Or you can simply write x equal to 58 over 19. But it's best if you put it in mixed number form. So, but again, we still need to check if our answer is correct. So let us check. So let's have 5x over 6 minus 3 plus x over 5 equals 4 over 3. You will say, Miss Tanya, this one is difficult because it's a fraction, but let's just try it. So 5 times 58 over 90. Let's just use the improper fraction. It's much easier compared with the mixed number because you still have to convert the improper fraction. Minus 3 plus 58 over 19 over 5 is equal to 4/3. That's equal. Okay, so let's simplify first. Multiplying 5 to 58. So 5 times 58 is 290 over 19 over 6 minus 3 and 58 over 19. So the LCD is 19 here. 19 times 3 is 57 plus 58 all over 5. Is it equal to 4/3? Okay, I hope that you're able to follow. Again, this is just a scale in fractions. Okay, so 290 over 19 divided by 6. Of course, the 19 and 6 will have to multiply here. So because both of them in the denominator. So we'll have 290 over 114 minus 57 plus 58 is 115 over 19 over 5. Is that equal to 4/3? So 290 over 114 minus 19 and 5 will multiply. 19 and 5 will multiply. So we will have 115 over 95. Is it equal to 4/3? Okay. So then we have to add 290 and 114. So let's, if we add that, so that's 290 over 114 minus 115. And 95. Yeah, it would give us 4/3. Okay, 4/3 is equal to 4/3. Okay, so this is our answer. So our answer is x is 58 over 19 or x is equal to 3 and 1 over 19. So there you go. That is how you simplify equations in one variable. I hope that you understood that. But of course, before we leave this video, I want you to practice on your own. So solve 7x minus 1, solve for the variable. 7x minus 1 equals 9 plus 5x. And then 7 times x minus 3 plus 12 is equal to 8 minus 3 times 3x minus 5. And x plus 5 over 2 is equal to x plus 4 over 3. Okay, so at this point, you can pause this video so that you can answer the questions on your own. And once you're done, you can play back or press the play button so that you can check if your answers are correct. Now, if you think you need to go back to the discussion that we had earlier, you can just rewind or move the, the video to the first part so that you can review and recall how to solve equations in one variable. But again, please pause this video so that you can answer on your own. So let's check if your answers are correct. So let's start with the first one. We have 7x minus 1 equals 9 plus 5x. So transpose here, this one transpose. So 7x minus 5x equals 9 plus 1. So 7x minus 5x is 2x. 9 plus 1 is 10. And divide by 2 to get rid of 2. Then we have x is equal to 5. So to check that, we will have 7 times 5 minus 1 equals 9 plus 5 times 5. So this 35 minus 1 is 34. 9 plus 25, and 9 plus 25 is equal to 30. Next, we have for number 2, we have 7x minus 3 plus 12, plus 8 minus 3 times 3x minus 5. So we will have here, should be in the parentheses, we have 7x minus 21 plus 12 equals 8 minus 9x plus 50. Negative times negative is positive. So this one needs to go here. This and this needs to go here. Okay. So we will have 7x plus 9x. We have to change the sign. 8 and 15, they will not move, so no sign change. And then negative 21 plus 21, positive 12 minus 12. So 7x plus 9x is 16. And we have 8 plus 15. We have 8 plus 15 plus 21 minus 12. 8 plus 15 plus 21 minus 12. So we have here 30. So if we divide by 16, x is equal to 2. And then again, to check if our answer is correct, let's check. So 7 times 2 minus 3, I'm doing direct substitution here, plus 12. Is it equal to 8 minus 3 times 3 times 2 minus 5? So 7 times 2 minus 3 is negative 1 plus 12. 8 minus 3, 3 times 2 is 6 minus 5. So this is negative 7 plus 12. We have here 8 minus 3 times 6 minus 5 is 1. So this is 5. And this is 5. Okay, so our answer is a true solution. This is our true solutions. Okay, for the last question, I hope that you also got this right. We have x plus 5 over 2 is equal to x plus 4 over 3. So again, if you have this kind of question, all you need to do is to multiply by its LCD. So the LCD of 2 and 3 is actually 6, right? So 6 divided by 2, that's 3. So I will have 3 times x plus 5 here. 6 and 3, that gives you 2. So I will have 2 times x plus 4 here. And then simplifying by distributing the number outside in the parentheses. So we have 3x plus 15 equals 2x plus 8. And then 2x goes here, 15 goes here. So 3x minus 2x equals 8 minus 15. And we have here x is equal to negative 7. So let us check if our solution is a true solution by checking, by substituting x is equal to 7. So x x is negative 7. So negative 7 plus 5 divided by 2. Is that equal to negative 7 plus 4 divided by 3? So negative 7 plus 5 is negative 2 over 2. Negative 7 plus 4 is negative 3 over 3. So this one is negative 1 is equal to negative x. Our solution x equals negative 7 is a true solution. I hope that you got all those practice exercises right. Again, you can always go back and do the first part of this video so that you can answer and understand more. And if you want more activities, you can email me, or you can simply answer the activities in your module. So again, I hope that you understood how to solve equations in one variable.